Over the last 60 years or so, intercontinental ballistic missiles, or ICBMs, have become the ultimate deterrent in the defence arsenals of the US, UK, Russia, China, France and other countries. This produced the doctrine of MAD, or mutually assured destruction, where if there was a nuclear conflict, no one would come out a winner. But as anti-ballistic missile systems, or ABMs, have become better in recent years, there is the belief that at some point a first strike by a country with a fully developed ABM system could lead to a winnable nuclear conflict if the retaliatory strike could be neutralised. However, in the last decade or so, a new class of hypersonic weapons has been in development that promises to be able to not only deliver a warhead to a target in record time, but also to do it in such a way as to make it almost impossible to shoot down. So how do hypersonic missiles compare to the decades-old tech of ICBMs, and are they really any better? This video is sponsored by Brilliant. So what are hypersonic missiles and why are they causing so much concern and a new arms race? Well, first we have to look at the ICBMs, and the clue is in the name: intercontinental ballistic missile. A ballistic object is one which is following a path under the force of gravity. A bullet fired from a gun or a bomb dropped from a plane are examples of ballistic weapons. Once they have been fired or released, they follow a predictable trajectory. An ICBM is no different. If one is launched from one point on the Earth's surface and aimed at another point maybe thousands of kilometers away, it will follow the same path each time. It will launch up into space, the launch phase, fly through space where it builds up its speed and does any course corrections whilst it's still under power, the mid-course phase. Then the payload will detach and the warheads and possible decoys will then fall to their assigned targets, the descent phase. Because the ICBMs fly high, they can be easily observed with radar and space-based tracking. It's in the mid-course phase, when they're in space, that they are most vulnerable and their trajectory can be worked out for ABMs to intercept them. Whilst this is doable, it's still extremely difficult and has been described as like trying to shoot a bullet with a bullet. The US has spent decades in developing ABM systems, and it's only in the last few years that they could say they had a workable solution, but it can only deal with a small number of incoming missiles at once, and it's strategically placed to intercept maybe 2 or 3 coming in over the Pacific from North Korea. Now imagine that you could launch a missile that would travel as fast as an ICBM, but instead of having it just fall from space onto its target, it could fly like a cruise missile and take evasive action. This now becomes virtually unstoppable with current ABM systems, and is exactly what the Russians and the Chinese are doing, because they believe that if the US can make its ABM systems tackle a much greater number of missiles, the balance of power would shift to the US and allow it to make a first strike, knowing that it could destroy any missiles sent in retaliation. There are 2 categories of hypersonic weapons: hypersonic glide vehicles and hypersonic cruise missiles. Hypersonic glide vehicles work a bit like an ICBM in that they are launched on a rocket into space, but then they descend to the top of the atmosphere and use the shockwave created by the body of the craft in a phenomenon known as compression lift to skim across it. Then, as it nears a target, it drops down and acts like a steerable hypersonic glider, which makes it much more difficult to target by an anti-missile defense system. Hypersonic cruise missiles can also be launched on a rocket or from a plane, but instead of going into space, they fly through the atmosphere like a normal cruise missile. The difference is in their speed. Instead of using a conventional jet engine like in the Tomahawk cruise missile, they use a scramjet engine, which only works above Mach 4, so they have to be initially boosted to that speed by a rocket. Then the scramjet takes over. This is where the hypersonic missiles have the upper hand, because they can use what's known as a depressed trajectory to fly at much lower but still hypersonic speeds of up to Mach 25 for the gliders, so they can get closer to the target before being detected. This not only leaves very little time for the opponent to figure out their course, they can also fly under existing ABM systems, which are designed to look for and intercept ICBMs coming in high from space and on a predictable trajectory. Their hypersonic speed also makes them almost impossible to shoot down at low altitudes, and they can maneuver so their course can't be predicted. Hypersonic cruise missiles also have been touted as extremely potent anti-ship missiles, because even without a warhead, hitting an aircraft carrier at Mach 5 or above would cause a lot of damage. It might not sink the ship, but it would more than likely put it out of action. But there is a problem with hypersonic missiles which is affecting all the countries which are developing them, and it's caused by the very thing which gives them their advantage, namely their speed. Flying at hypersonic speeds in the atmosphere creates a tremendous amount of heat, which increases with speed. The SR-71 Blackbird spy plane flew at Mach 3.2 at 70,000 feet, where the air is only about 5% of the density as it is at sea level, and that caused the leading edges of the wings to heat up to 560 degrees Celsius. That's hot enough to melt some aluminium alloys. The warheads of ICBMs also travel at hypersonic speeds during their final descent stage, but only for a minute or two, and they use an ablative heat shield to protect them, much like a returning spacecraft. Hypersonic weapons, on the other hand, travel almost their entire journey, which could be thousands of kilometers, at Mach 5 and above. At sea level, where the air is at its densest, the maximum speed of these missiles is about Mach 7. The heat created at these speeds can cause the materials that the missiles are made out of to exceed 2000 degrees Celsius, so they have to be made out of exotic composites. At these temperatures, the air starts to chemically react with the materials, causing them to break down. It's also hot enough to cause plasma to form around the vehicle, which can affect the GPS guidance systems and course correction commands sent to it from outside. This also affects the accuracy of the missile. At hypersonic speeds, variations in the wind, temperature and other environmental factors are magnified, making it much more difficult to target something like a ship accurately compared to a normal subsonic cruise missile. Hypersonic weapons also place the leaders of the country being targeted in a very difficult position, because there is virtually no difference between a nuclear-armed missile and a conventionally armed missile when it comes barreling over the horizon at several kilometers per second. And with so little time to react, they might just order an all-out retaliation rather than wait to see how big the bang is, which is why they are seen as being so destabilizing. At the moment, there is virtually nothing that can stop them except the equally exotic directed energy weapons, which are even further down the pipeline than the hypersonic weapons themselves. But with upgraded space-based detection, it will be possible to track the hot missile bodies almost from their launch, which will give about the same amount of warning time as that of a normal ICBM. So it's unlikely to affect the balance of power for a while, because there is still no practical way to defend against a full-scale attack from dozens to hundreds of ICBMs. So even if Russia or China were to have hundreds of hypersonic missiles, the US still has at least 1,500 warheads that it could retaliate with. Now, the US has been seen as being in a bit of a catch-up situation on hypersonic weapons, with both China and Russia taking the lead, even though the US has been working on them for decades. The thinking in the US was that an ABM shield was a better approach, something which we can now see that can be sidestepped with hypersonic technology, which just illustrates the point that things don't stand still. What's a good idea today isn't necessarily going to be a good idea tomorrow, and you have to keep learning new skills and techniques. Which brings me rather neatly onto our sponsor for this video, Brilliant. Brilliant is a problem-solving website that can help you develop your learning skills by breaking down complex problems into small, easily understandable parts, then putting them back together to show the overall solution build up to an interesting conclusion. There are loads of totally great interactive courses, and as we saw in this video, missiles are all about maths and kinematics, the language of everything that moves. So why not start with projectile motion and how arrows follow a ballistic path, along with much more. This hands-on active learning approach is great for curious people like you who want to understand the world. So if you want to support Curious Droid and get unlimited access to all of Brilliant's in-depth math and science courses, head on over to brilliant.org/CuriousDroid to get 20% off of their annual premium subscription.